Welcome to Mechanotechnics N6. This video is on balancing. So what is meant by balancing? Well, in engineering, when we talk of balancing, what we mean is that we correct the unwanted forces and moments to an acceptable level by changing the location of the center of mass of the system. So if that definition was a mouthful, I can simplify it to you this way. Imagine that you have a disk that is rotating on a shaft, and then the mass of the disk is not evenly distributed. So the disk is maybe thicker on the one side than it is on the other. So when that disk begins to rotate on the shaft, what will happen, because you do not have masses evenly distributed on the disk, due to the rotation of the disk on the shaft, what will happen is that centrifugal forces will begin to act on that disk. But because the centrifugal force is proportional to the mass, so the sections of the disk where you have a higher mass will have a higher centrifugal force than the sections on the disk where you have a lower mass. And so if those masses are not evenly distributed, the centrifugal forces acting on the disk will also not be evenly distributed. And that will give rise to unbalanced forces on the disk. And because of that, the shaft will be under extreme loads, and those loadings will not be constant, but they will be fluctuating because the disk is rotating, and that is not good for the shaft. So what is done in engineering is that we add masses that will create other inertia forces that will then balance the centrifugal forces in such a way that the forces acting on the disk are all balanced, and in that way the shaft will not be experiencing unbalanced fluctuating loads. Okay, so that is a lot of theory, but as we go through the examples, all of that is going to make a lot of sense. So, but before we do that, I want to remind you of some of the important concepts that you learned in Science N3 and in Science N4. So the first concept I want to remind you of is that of the resultant. So whenever we spoke of the resultant of two or more forces, what we meant by that was the one force that could replace all the forces in the system and still produce the same effect. That was what was meant by the resultant. The resultant is one force that can replace all the forces in the system and still produce the same effect. Said in other words, the resultant is the sum of all the forces in the system. Okay? And then, besides the resultant, another very important definition I want to give you is that of the equilibrant. Okay? The equilibrant. Now, the equilibrant is that force that will balance all the forces in the system. In other words, if you sum all the forces in the system and you get the resultant, then the equilibrant will be the force that balances that resultant. In other words, the equilibrant has the same magnitude as the resultant, but will have to act in opposite directions because it's supposed to balance the resultant. So the equilibrant is the one force that you need to add to the system in such a way that the system is in equilibrium. What is meant by that is that by adding the equilibrant to a system of forces, then if you do the sum of forces, then you will get zero, because that equilibrant comes and balances out the resultant of all the forces in the system. Okay, so very important. So again, I will repeat, the resultant is the one force that you can place in the system that will replace all the forces acting in the system and still produce the same effect. Okay, that's the resultant. And said in other words, the resultant is the sum of all the forces in the system. But the equilibrant, on the other hand, the equilibrant is the one force that you need to add to the system so that the system becomes in equilibrium. And the equilibrant is opposite in direction to the resultant, but must have the same magnitude. So if you can picture the resultant acting in a certain direction, okay, and then you bring the equilibrant, which will have the same magnitude as the resultant, but act in the opposite direction. That's the definition of the equilibrant. Then if you sum the two, you will see that the resultant is zero. So that's exactly what the equilibrant is. It's that one force that you add to a system of forces in order to balance the system, or in order to make the sum of all the forces in the system equal to zero. And remember, the equilibrant has the same magnitude as the resultant, but acts in the opposite direction. So that is very important. These two definitions are very important because we make use of them when we are solving problems on balancing. So the first example that I am going to present you with is still a recap from the past. Okay, so let's look at it. This question says, find the magnitude and direction of the balancing force using a vector diagram and indicate your result in a space diagram. And then they give you a scale. They said use 1 millimeter is equal to 1 Newton. So you have these two forces, okay, this system of two forces, and the two forces are at an angle of 150 degrees with each other. The one is 50 Newton east, and the other one is 30 Newton in that direction. Okay, and so what they ask you is to find the magnitude and direction of the balancing force. And the mere fact that they referred to it as the balancing force, that tells you that it is the equilibrant, because the equilibrant is the one force that you will add to this system and that will balance the whole system. In other words, it's the one force that you need to add to this system for this system to be in equilibrium. Okay, and so as I said earlier, the equilibrant has the same magnitude as the resultant, but it is opposite in directions. Okay, so when we have to find the equilibrant or the balancing force, first what we need to do is to find the resultant to this system of two forces. And so because you are told in the question that you need to use a scale of 1 millimeter is equal to 1 Newton, so a force of 50 newtons will be equal to 50 millimeters. And so what you will do, you will pick a point where you begin with your space diagram, and you can call that point 1. And because the 50 newtons force is pointing directly east, so you will go in that direction, but you will measure 50 millimeters, because we are turning every force in newtons to its equivalent in lengths in millimeters. And for the way we do that is using the scale that is given to us in the question. 1 millimeter is equal to 1 Newton. Okay, so the 50 Newton force is a length of 50 millimeters. And so the next thing that you do is to draw the 30 Newtons force. And of course, based on the scale that we have, this 30 Newtons force will be a length of 30 millimeters. Now, you could choose to use the parallelogram method to find the resultant of two forces graphically. And so what I mean by that is that you could complete the parallelogram, because you can see the 30 Newtons force and the 50 Newtons force constitutes they constitute two sides of a parallelogram, and so you can pretty much fill and complete the parallelogram, and then the resultant will be the diagonal going from the origin of the forces to the other point of the parallelogram, the other corner. And so that will be your resultant. That's one way of doing that. But the way that we prefer when we're dealing with balancing is to put the forces head to toe, if you see what I mean, okay? So the origin of one force will be, let's say one origin is 1, and then the end of the first force is at point 2. And at the end of the first force, that's where you begin to draw the other force, okay? And if you had 3 forces, the third force will begin at 3. and go in whatever direction it